this is being recorded, just so y'all know. All right, so Unit 3, we're going to talk a little bit more about exponential and logarithmic functions. This time we're going to talk about using the properties to solve logarithms. All right, well, yesterday we talked about if there is nothing down there, if it just says log with no base, it's understood to be a base 10. If you look on your calculator, you have that button as well, but you also have an LN button. The LN button is a log. It means a log with a base of E. Now, E is a number just like pi is a number. It is an actual number, okay? One of the things I want you to notice, like if you say the natural log of E, that equals 1. So E to the what power equals E? Well, 1. Just like if you say the log of 10, that's going to also be 1. Okay? Everything all the properties that you use for the logarithms are also used for the natural logs. Okay? All right. Now, the addition property, I always think about addition and multiplication go hand in hand. So if you have a logarithm and two arguments right here that are being multiplied, then you can split those up. And you can say log base b of the first one plus log base b of the second one. You can also go the other way around. So if it's split up like this with the plus, you can go the other way. You can go backwards as well. All right, so if I expand this right here, log base 3, 4 and 7, 4 times 7, it's going to be log base 3, 4 plus log base 3, 7. Okay? You try to expand this one real quick. Okay, hopefully you got that. All three of these are being multiplied together. So it's going to be log x, because it's a base 10, plus log y plus log z. Get up. Hopefully you guys did great on that one. All right, so now let's go the other way. Let's condense it. Oh, we didn't condense example 2. We didn't condense that. Go condense example 2 and condense this one as well. Go do both of those. Okay, so if we're going to condense this, why is it not writing? If we're going to condense this, it's going to be log base 6 because they all share the same log with the same base. So then we're going to multiply all these together. I'm going to go ahead and put the 7 right there and then the x right there. So that's what he wants you to do. All right, on this one right here, it's going to be log base 4. I'm going to put the 9 first. Then you can do x and then m. All right? There you go. Make sure when you're writing your logarithms, make sure your base is down below. It has to be a subscript. Sometimes people write them and it looks a little like this would be a log base c, but it's really a log z. Make sure you're paying attention to how you write it, okay? All right, so now the same thing's going to work with division and subtraction. All right, so if I have something that's being divided, m divided by n, I can pull that apart and make it log base b m minus log base b n. Make sure whoever's on top comes first. They need to come first. That's the big deal for that one. All right, so let's expand this one right here. All right, so if I expand that, I'm going to say, down here, log base 4 x minus log base 4 y. Got it? All right, now you try to expand this one. Okay, so we should have the log base 7, 5 minus log base 7, 9. Again, pay attention that the top one goes first, and then you're subtracting the bottom one. All right, now condense both of these right here. You condense both of these. Okay, on this first one is the example. It's log base 4. Now remember, the first one goes on top, second one goes on the bottom. All right, try the next one. Log base 2x over m. All right, how are we doing? All right, so power and coefficient properties. Now, if you have a log that has m to the p power, so the argument right there has its own exponent, you take that exponent and put it out in front of the log. Put it out in front. All right, so let's do this one. For this, I'm going to take the 4 and put it out in front of the log. So he is the exponent of here, of this x. Then I'm just going to write the rest of it the same. All right. You try one. Okay, on this one again, we're taking the exponent of the y and putting it out front. And we got log base 47 y. Again, make sure that you're putting that base low enough. Like if you're in kindergarten, you know that it's below where the line is. Okay, so now let's condense this one. I'm going to go ahead and do this one for you. If we have this, we're going to take the log base 12 x, and then I'm going to take this thing out in front and put it as an exponent right there. All right? Try the next one here. Okie doke. We're going to take the log base 9, put the c there, and then we're going to take this little dealio and we're going to put it as the exponent right here. So 7 over 4. Again, make sure that this is an exponent. Make sure when you're writing it, you can really tell what everything is. All right. So here's the really important thing. If you see a square root in a problem, you have to convert it to a rational exponent. Remember, the index becomes the denominator of the exponent. So let's look and see what they're talking about. So this is an understood 2 right out here on that radical, and this is an understood 1 right there on the exponent of the inside the radical. So it's log x to the 1/2. Well, then you're going to take that exponent and you're going to move it out to the front. Big deal. Okay, so let's try this one. Expand this one. So the first thing I'm going to do is I'm going to put log, oh goodness gracious, log base 9, and I'm going to put in parentheses 8x, and I'm going to put that to the 1/2 power. Okay. Then I'm going to take my 1/2 and I'm going to put it in front of the log. All right, but I'm not done. I'm not done yet. So now I'm going to take the 1/2. I'm going to go ahead and put this in parentheses. Some people don't. I just am going to. 8 plus log 9x. So because I know you're sitting there thinking, oh, that's just 8x. Those two are being multiplied together. Those are being multiplied together. So you got to expand all of it, okay? All right, you try this one. You try that one. So the first thing I'm going to do is I'm going to say, oh, snap, go backwards is what I'm going to say. I'm going to say log base 12, and I'm going to put this in parentheses, x over z to the 1/4 power. Because this guy in here is like in parentheses to the first power. So that's to the 1/4 power. X, I'm going to bring my 1/4 out, put my log 12 there, log base 12 there. And then I'm going to put my X right there. Am I done? No, I am not done. Again, I like parentheses here. Log base 12 Z. Okay. Try the next one. Oh, Nelly. Expand this guy. Alrighty. So for this guy, what we could do, let me think on this one. All right, guys, we're going with this answer right here. We're saying that since the 5 is really kind of like an exponent up here, and this 4 isn't attached directly to the X, so it's not like this. We can't subtract these. So the log doesn't apply to the 4. He's not in there with the X. So it really kind of looks like this guy right here. Oh, that's a beautiful arrow, isn't it? And then it can also be written as that right there, either one. But to me, that's weird because it's not an expand. So I'm kind of a little leery on that one. All right, let's go to the next one. Let's see how we do here. Oh, it just keeps messing with me. All right, so what it says, putting it all together, expand or condense the following logarithms using properties listed above. Okay, I think that they meant to say condense a minute ago. So this one says expand or condense. So let's try each one of these. Go ahead and try each one of these. Okay, so what we did is we took the exponent. Well, first of all, we broke up the multiplication here into addition. Then we took the exponent for each one and put it out in front. All right. Try the second one. Okie doke, guys. What we got here is we broke it up. Since it's division, we broke it up into subtraction. Then we took the exponents and put them out front. Don't forget, we still have the base 5 for both of them. So we took the 3, put it out front, and the 7 and put it out front and subtracted those two. Awesome. All right, try C. Okay, so there's a lot going on in this one right here. So you got to take each one of them and separate it out. So the G and the H are being multiplied, so you got to put addition between those two. And then the K is being divided, so you got to subtract that. Then for each one of them, you got to take the exponent and put it down in front. Boo, 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 boo. Yay! You guys are rocking. All right, so let's try this. Putting it all together, expand or condense. So this one right here, we're going to be condensing. So get to condensing here. See if I can get this to pause. So because the 5 is out front, we're making him the exponent of the X. All right, so he comes out to be the exponent of the X. So we put log base 2, X to the 5th. Then this addition means we're going to be combining them as multiplication. And then the 7 comes as an exponent of the Y. So there you go. Ta-da! All right, try E. So for this one right here, what we did is they're being subtracted, so that means they're being divided right here. So they both have the same base. So we said log base 5. We took the 6 and made it the exponent of the G, and the 9 the exponent of the B. We can't forget that the G goes on top because he's first. Nope. All right, try F. Okay, so everybody has a log base 4, so we went ahead and put log base 4. The 7 goes with the exponent with the X. He's hanging out there with the X. And the 6 is the exponent of the Z. These two are being